Hello everyone. Today we are going to talk about a very important topic, antimicrobial drugs. Now we have all heard about these drugs, but I want to clear some of the basic concepts regarding antimicrobial drugs. Now there are two broad terms in this thing. Now there are two broad classifications and two broad terms in this thing. Number one, there are the antimicrobial drugs and then there are antibiotics. Now we mostly tend to confuse both of these terms and we must not do that. So let's get into it. Now antimicrobial drugs, this term is a very broad classification. This is a very broad term. It includes all of the antibacterials, all of the antivirals, and all of the antiprotozoal, antiseptic drugs. Now, any drug that inhibits, kills the growth of any microorganism is called antimicrobial drug. That could be anything. That could be a bacteria, that could be a fungus, that could be a viral, and this term could have any origin. It could be of natural origin or it could be of animal origin. So we classify all of those drugs into antimicrobial drugs. Now there is another thing, another term called antibiotics. Now we come across this term very often and we don't know the extent of it that are produced by various species of microorganisms. Now you have to focus on this part that these are the drugs that are produced by various species of microorganisms. It means that these are the drugs that are produced by microorganisms and they kills or inhibit the growth of another microorganism. So the origin is very important here. For any drug to be antibiotic, it must be originating from any other species of microorganism. It could not be of synthetic origin. And most of the drugs that are classified into antibiotics are our antibacterial drugs. And most of our antimicrobial drugs could be antibacterial, antifungal, antiviral, antiprotozoal, or antiseptics. Now this is the point I want to remember that antimicrobials are could be of any origin. It is a very broad term. And antibiotic, these drugs are specifically of microorganism origin. These drugs should originate from any other microorganism. Now we will classify our antimicrobial drugs in a very broad way. Now let's get into it. This is a general classification of antimicrobial drugs. Now, antimicrobial drugs are classified into cell wall synthesis inhibitors that could be penicillins, cephalosporins, carbapenems, and vancomycin. Now we know that any bacteria have certain types of peptidoglycan inside their cell wall, and they have an enzyme called transpeptidase. Now this transpeptidase is an enzyme that makes the cross bridges between the two amino acid moieties. Now this is a bond between two amino acids. Now cell wall synthesis inhibitors, penicillin, cephalosporin, carbapenems, and vancomycin, they block that cross bridging between the two bacterial walls, and they basically inhibit the formation of peptidoglycan links in the cell wall. So when this happens, this bacteria cannot have any cell wall and they will be lysed by the osmotic pressure. Now this type of drugs are mostly these drugs are called bactericidal drugs. Now these drugs kills the bacteria. These drugs do not inhibit the growth of the bacteria, instead they kill the bacteria. Moving on to the next classification, this is of ribosome inhibitors. Basically, they are protein synthesis inhibitors. As we know that we have our central dogma in which there are ribosomes and RNA comes from to the ribosome and it gets translated from the ribosome. Now these are the drug that binds to the most of the drugs bind to the 50s component of the ribosome and some binds to the 38 component of the ribosome and they block them, hence they block the protein synthesis, and when the protein synthesis is blocked, the bacteria cannot grow. The growth of the bacteria is diminished. Now such type of drugs are mostly these are the bacteriostatic drugs. meaning that they inhibit the growth of the bacteria. Moving on to the next classification, antimetabolites. Now, antimetabolites are the drug that blocks the metabolic reactions that are occurring in the purines and pyrimidine portion of the DNA. They block their metabolism, these antimetabolites. Now, these drugs are sulfonamides and dapsones. Now, sulfonamide is also it itself a very broad group and it contains a lot of drugs, and also dapsones are also a very broad group. Moving on to the nucleic acid synthesis inhibitors. As I mentioned, there are DNA consists of purines and pyrimidines. Now, purines and pyrimidines, these are the two types of nitrogenous bases that are present inside the DNA. Now, both of these nitrogenous bases are blocked by certain type of drugs that are curinols and rifampicin. Now, rifampicin and curinols, they bind to these bases and they most of the time replace them. And when they replace them, they alter the DNA. And that altered DNA cannot be of any that cannot perform any type of specific and specific growth. So these are called nucleic acid synthesis inhibitors. So as far as we have our cell wall synthesis inhibitor that are penicillins, cephalosporins, carbapenems and vancomycin. Then we have our ribosome inhibitor or protein synthesis inhibitors PSIs. They are our tetracyclines, macrolides, chloramphenicol, clindamycin. We have our antimetabolites that are sulfonamides and dapsones. We have our nucleic acid synthesis inhibitors that are curinols and rifampicin. So this much about the general classification of nucleic acid synthesis inhibitors and our antimicrobial drugs. So if you guys have any question and if you want any other topic to be covered, drop down into comment and we will get back to you with more such and more easy videos. Thank you guys for watching. Do like and subscribe and share it with your friends.